Okay, Miss Mills here, working on the homework from 4.1 in the MVP Math Module 4. Topic, solutions. This is the ready section. Solutions to an equation. Graph the following equations on the coordinate grid. Determine if the given point is a solution to the equation. That's not really a question. Okay, so this is kind of light here. So I want to always find my 0. That's, for me, that helps. All right, this is written in slope-intercept form. My intercept is -2. So on the y-axis, my y-intercept is -2. My slope is 5. So 1, 2, 3, 4, up 5 and over 1. Okay, I'm going to check that by saying if x is 1, that's 1 times 5 is 5. 5 minus 2 is 3. 1, 2, 3 makes sense. Let's see if I can do this. In this paper, I'll do my best. Okay, they're asking me, is the point 1, 3 on the line? Oh, I just checked that. 5 times 1 is 5. 5 minus 2 is 3. Yes. I'm going to do the point first, because if I know it's on the line, that'll make it easier. So it says the point 0, 7. So -1/2 times 0 is 0. 0 plus 8 is 8. So no. And let's see, looking at that by looking at the line. It's going to go through +8 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8. That'd be there. And it's going to have a negative slope, which goes that way, down 1 and over 2. Down 1 over 2. 2, 2 over 4. And so on. Okay, they're not perfect when you're using a pencil. So the point 0, 1, 2, 3, 4, 5, 6, 7, it's not on that line. It's the point 0.8. That's what they're wanting you to notice there. All right. So all of these are in slope-intercept form. So when you have that slope-intercept form, the fraction is no problem. It's not complicated or tricky. If you're not trying to solve it or anything, all you're trying to do is graph it. It's just a slope. So let's do this one, because this one, oh, it looks terrible. Ah, it's got a big fraction, improper fraction. Not tricky at all. Let's see, let's find our 0 here, right there, our origin. We want -7 for our y-intercept. 1, 2, 3, 4, 5, 6, 7. And we want to go positive direction, up 5 to the right 2. 1, 2, 3, 4, 5, 1, 2. That's all. Now, this is really hard to see, so if you ever want to use your own graph paper, feel free. I might do that if it were me doing this homework, but I'm doing it on here. Maybe next time I'll use my own graph paper. It might be easier. Now, let's see if we think the point 2, -2. So if I go +2 in the x direction, -2, yeah, pretty sure that's on there. And let's do the math. Okay. So as I said, the point 2, -2 looks like it's on there. So I'm going to take this rule. I'm going to say 5/2 multiplied by 2, because that's an easy thing to do, minus 7. So reminder, this is the same thing as saying 2 divided by 2, because a fraction is really a division problem. This means 5 divided by 2. It's just that we use fractions to think about parts of things, so we often think of it as a part of a thing, but it's also a division. So 2 divided by 2 is 1, so we just say, oh, that's a 1. It's supposed to look like a 1. 5 times 1 is 5, so this is 5 minus 7. Okay, use our integers. Well, 7's bigger, so obviously I'm going to have to end up in the negative region if I try to take 7 away from 5. So I'm going to end up at -2. So yes. All right. I didn't have you do the set, so I'm going to skip that for now on this video and get to that another time. Let's look at the go. Determine if a number is a solution to an equation. Okay, here's the directions. Indicate whether the given value is a solution to the corresponding equation. Show your work. Okay, here's the corresponding equation right here. 4a plus 3 equals -9. Question is a -3? This is a guess and check. Is 4 times -3 added to 3 -9? I'm going to do some mental math here. See if you can follow this. I know I'm going to have -3 added to itself 4 times. -3, I'm going to have 4 -3's here. And one of those -3's is going to cancel out with the +3. So if I had 4 and 1 goes away, making a 0 here, then I have 3. So what's 3 times -3? -9. Oh, I think this is true. Let's do it a different way. Let's multiply it out. 4 times -3, positive times a negative is a negative. 4 times 3 is 12, -12. Add 3. Okay, well this is a different way of saying 3 minus 12. So you could think of it that way, like, oh, 12 is too big. If I tried to take it away, I'm going to be in the negatives. How far in the negatives? Well, you find the difference and keep the sign of the larger absolute value is another way of thinking of it. So 12 minus 3 is 9. 9, 10, 11, 12. Count up in my head. Always check your work. Don't feel bad about using your fingers. And it's -9 because there are more negatives than positives. So the answer is yes. All right, this one looks tricky. It's got a decimal. Let's see if it's tricky. 2. No, that's not going to be tricky at all, because I'm just thinking of this as this is $2.50. Well, if I have $2.50 times 2, that's $2.50 plus $2.50. That's $5. Let's show the math of it. 2.5 times 2, 5. 2 times 5 is 10. 2 times 2 is 4. Add another 10 and that's 5. So the question is 5 minus 10, what does that equal? That equals -5. So the answer is no, it's not equal -0.5. Okay, over here, there's 2 different ways to think about this. You could use the distributive property, but that would be kind of more work than is necessary. Why do I want to distribute it out when I could just add it up? So 6 times 5 minus 2 is on the left. And does that equal yes or no? 4 times 5 plus 2. Okay. Now, you don't have to write it out if you could do it in your head. I'm going to do it in my head. 30 minus 2. 4 times 7. They both are 28. 4 times 7 is 28. I know that. Memorize your 7's timetables. You need to know them. 30 minus 2 is 28 because if I think about it, 28, 29, 30. Okay, if I count up, I get to 30. So that would be yes. All right. So these are things you really need to be able to do. This is like a basic of algebra right here, being able to plug numbers in and find solutions, being able to use decimals, being able to know your times tables. Okay, these are all things you really need to make sure that you've got. All right, later.